So page 269. So we're supposed to learn about this Kepler guy. Well, who is he? What did he do? And what's going on with him? So let's read at the top of page 269. Johann Kepler. Did you guys know that Mr. Williams' real name? Did he tell you why he's named that? Because for generations, like for like 10 generations, the firstborn son is always named as Johannes Dirk, and so that's what his name is. Yeah. Anyways, okay. Johannes Kepler was a German mathematician with a strong interest in astronomy. When he started working for renowned Danish astronomer Tycho Brahe in 1600, he was given the problem of determining why the orbit of Mars didn't completely agree with mathematical predictions. Brahe probably gave Kepler this job to keep him busy since he didn't share Kepler's ideas that the planets revolved around the sun. Because at this time, most people, including scientists, believed that the planets and the sun revolved around the Earth. So Kepler did some research on this, and he was very instrumental in basically understanding what's happening in space and why planets revolved around the sun and not around the Earth. So this is what he was up to. So let's write that down in our background information. Kepler was given the job to determine why the orbit of Mars didn't completely agree with mathematical predictions. And then I think it's important to note just the societal view at this time, that at this time, most people including scientists believed that the planets and sun revolved around Earth. So Kepler did a lot of planetary studies and observations. So he was very interested in astronomy. So he made 3 laws of planetary motion based on all of these observations. So we're not going to talk about all of the observations he made. We're just going to talk about the 3 main conclusions or laws he drew from them. So the first law is that planets move around the sun in elliptical orbits, with the sun at the focus/center. So center and focus mean the same thing of the ellipse. So we can see here, if we look at the sun and Earth's orbit around the sun, it's an elliptical shape, not a circular one. So you can just make a note, this is elliptical. not circular. Now, eccentricity means the degree to which an ellipse is elongated. So, and it's measured between the numbers 0 to 1. So if we looked at it with 0 is being a perfect circle, and 1 then would be a flat line. Anything above 0, not including 1, is a parabola. So I want you to turn to page 270 now. And on the side is table 5.4, just on the top left-hand corner. And I want you to read that. It's the eccentricities of orbits of celestial bodies. So like Venus is 0.07, that's going to be a lot closer to being more circular, even though it's still an ellipse. When we look at Sedna, it would be like a really flattened kind of parabola, almost looking like a flat line, because it's that much closer to 1. So it would look like that.
Where's Sedna?
It says right below, Sedna was discovered in 2004 and is the largest object yet found in a region of space known as the Oort cloud. On July 29, 2007, an object now named Eris was confirmed. It is larger. What does it really tell us? I don't know.
What about this Eris?
What's Eris thing?
Are these like French lines or something?
No, those wouldn't be planets. They might be moons orbiting planets. It's probably, that's my guess. We can look it up.
I thought it was actually a dwarf planet.
Yeah, Pluto doesn't count as a planet anymore. Well, so, do you have your phone? You? Who has a phone? Nobody? You have a phone? Look up what Sedna is. Addison, you have yours? Can you look up the Sirius one?